So exponential functions are different from what we've been talking about so far because of where the variable is located. Just for example, here's one, f of x equals 5.2, and then raise that to the 4x power. So exponential functions are functions like this one where we have the variable, notice that, is located in the exponent. Hence the name exponential functions, and that's different than we've been so far talking about because the powers we've had so far have just been numbers. But in this particular case, for exponential functions, the powers will be will contain the variable. And so one thing they have us do is evaluate this. And so let's evaluate it for a couple of different values of x. So evaluate this for x equals 2. So f of 2. So x is 2, so that'd be 5.2 to the 8th power. And yeah, so those, just put those in and see what we get. The 534,597. Yeah, and that's one thing to note. Yeah, these, since the variable has the exponent, a lot of times, or on some of these values, they're going to get quite large. I mean, I guess we could have had with the others, but this is only to the 8th power, and that's, we're talking 500,000, over 500,000. So that's one of the things we'll talk about with the exponentials is how they get large quite fast, or these particular ones. Now, the a couple other things I wanted to mention. What do we get if we've got x is 0 here? Or f of 0? Well, 4 times 0, so it'd be the 0 power. And what value is always anything to the 0 power? 0. Not 0. 1. It's 1, yeah. Anything to the 0 power is 1. And that will come up a few times along the way here. So yeah, anything to the 0 power gives you a value of 1. Now, let's also evaluate this for x equals -3, or something like that. Of course, you don't have to know this to evaluate this one, but so it'd be 5.2 to -12. Is that going to give you a negative number? Why doesn't that give you a negative number?
Because it's even on the exponent?
Good guess. Yeah, you get, well, mine says 2.55,834,9515. Put it all out here. This is what mine shows. And yeah, this E for exponent, but it's also noteworthy here. It's not this to the -9 power. It's this is scientific notation, and some calculators show it differently. This means times 10 to the -9 power. So it's really 2.55834. Get all those in? Yeah. 9515 times 10 to the -9 power. So that's one thing I was going to mention on that. That's what your calculator shows. It's really scientific notation. But, and of course, this means 10 to the -9 power means if we wanted to change it to where it wasn't scientific notation, move that back 9 places. So it is not a negative number, and anybody tell me try again why this isn't a negative number. What does a negative power really mean? A negative power means flip it over, right? So this really is 1 divided by 5.2 to the 12th power. And so you do not get a negative number there because it's just 1 divided by a large number. But so that's why you get a small number here. It's a very small number. Yeah, so ones like these where we have a number, a base to a power, just like that. You won't get any negative numbers. You'll get small positives, but you won't get any negatives like that. So just a couple of reminders there.
And we can write it either way, right? Like any of those options.
Yeah, that's either one will be okay, yeah. As long as you know what it means. All right, so let's start with, next go to look at what some graphs of these look like. So let's graph some basic ones here, and then talk about shifting them too. But so let's say we've got f of x equals 2 to the x. Well, go to our old stand by the table here. You can always talk about some values in the table. And let's start at x is negative 2 and then work our way up to positive 2. And then maybe that'll show us enough here to figure this out. All right, so if x is negative 2, we've got 2 to the negative 2. And it says you don't have to know that that means 1 over 2 squared, but it does explain why you get what you get. 0.25, right? Is what you would have for the y value there. To the negative 1, so that's going to be a half, 0.5. X is 0, so that's our 2 to the 0. Yeah, that's 1. And then we get 2 to the 1, and then 2 squared. And let's add one more, 2 to the third. Go up to 3 there. So we get 8. So yeah, we get this graph right here. So at negative 2, I'm at 0.25. At negative 1, I'm at 0.5. At 0, I'm at 1. 1, 2. 2, 4. And then 3, 8. Okay, so yeah, it's hopefully obvious there that over on the right, as far as in behavior goes, those numbers are getting quite large quite fast. The next one would be 16, right, if we went to the next integer anyway. So yeah, that side there is definitely going up to infinity, quite large, quite fast. Over here on the left end, though, what do you see happening there? Are those going to come below the x-axis anytime, or what's going to happen over here?
Level out.
It's going to level out, isn't it? Because of what we were just saying about the negative powers, right? The negative powers, you don't get a negative number there. They'll just flip over, and so you get small numbers, or numbers close to 0. Yeah, so these are, just like you said there, they're going to level out. So what do we got, what do we call that type of behavior on the end like that? Asymptote? Horizontal asymptote? Yeah, we've got a horizontal asymptote here on the left side. Y equals 0. So it's different from those, you know, on the rational functions, most of those that we did were horizontal asymptote on both sides, but here on the exponentials, you've got a horizontal asymptote on one side. In this case, it's on the left. That can flip around, I'll show you in just a second, but Yeah, so this is the basic graph of an exponential function. I've heard it explained, called a hockey stick, maybe type graph, because of the shape there. It kind of has the shape of a hockey stick. But that's what exponentials, or these basic ones anyway, they look like.
Would it be accurate to say that that horizontal asymptote infinitely gets closer to that axis?
The x-axis, yes, in this case. Now, the other thing I was going to mention here, we haven't talked about increasing and decreasing function, but this is a good time to talk about that. An increasing function is one, as you go left to right, that goes up. From left to right, you're headed upwards. And so if you look at, maybe it's not so obvious here, but obviously as we go left to right on the graph, that graph is going up. And so this is an example. This is a function, an increasing function is what we would say there. So the function is increasing. And that's another kind of designation, because we'll look at another version of an exponential function here in a second, and it'll be kind of the opposite, and so that's another distinction we can make. This is the increasing version of the exponential function. All right? Now, just a little more clarification on the increase. Why do we say that's increasing? It's because of the function value. As you go left to right, if we jump from x value 1 to x value 2 to x value 3, the function values are increasing there. Because you go from 2 to 4 to 8. So the function values are increasing is what we mean by that. All right. Well, let's contrast that to this one. F of x equals 2 to the minus x. And what we'll see there, if we just look at the table, is a similar things happen, just at different x values, right? Because what's the y value when x is negative 2?
Very positive.
That's going to make the exponent positive, right?
Mm-hmm.
Oh,
And so that would be 2 to the second. So that's going to be where the 4 is. It's at negative 2. And then when x is negative 1, we'll have 2 to the negative 1. So that would be 2 to the 1, which makes that 2. And so yeah, it just flips things around, doesn't it? X is 0, we've still got 2 to the 0, so that's still 1. When x is 1, that's where we have 2 to the negative 1, right? So that's the half. And then 2 to the negative 2, x is 2, then y is 2 to the negative 2, so that's our 1/4, 0.25. So yeah, things have just flip-flopped, if you will. So now at negative 2, that's where I'm at 4. Negative 1, I'm at 2. 0, I'm still at 1. 1, I'm at a half, and 2, I'm at a fourth. So yeah, things have just, like I said, flip-flopped. If we want to be technical about it, it's been reflected how? Through
Y-axis.
the y-axis, yes. But anyway, it turns it into this shape, which is still a hockey stick, but what's different about it? Well, for one thing, the horizontal asymptote's on the right, isn't it? We do have the horizontal asymptote at y equals 0, but it's on the right instead of the left. And the other thing that's changed, and again, the distinction here, instead of increasing, what do we have here? It's decreasing, yeah, from left to right, the graph is decreasing. So our function is said to be decreasing. And again, that's because the function value is decreasing. If I go from -2 to -1, the function value decreases because I go from 4 down to 2, so it's the function value that's decreasing there. All right, so yeah, so the basic shape of an exponential function, hockey stick. Sometimes you'll see these two listed this way. In general, we call the base base A. Now the only thing, so that one would look like 2 to the x, as long as we have, so let's look, whoops, the other way. The only real note there that we need on that is the base, the A here, can be any number, but for it to be this shape, A has to be greater than 1. So any number bigger than 1, plug that in, make it to the x power. That's the shape that you're going to have, this hockey stick shape. The increasing graph, horizontal asymptote over here on the left. And then if you've got f of x equals a to the minus x power, then that's the decreasing variety there. So long as a is greater than 1. Just gives you an idea of what those should look like if you come across those and think about the graph. All right, now what they'll do with these, or what will have you, as far as graphing concerned, do with these is for some shifting. But good news is the shifting is the same as before. What kind of shift is that going to put on this graph?
Shift
The
to the
plus
right.
2.
No.
The plus 2 on the outside, right? And remember on the outside, if you go plus or minus on the outside, that shifts it up or down. And the plus goes like you would think, it goes up. So this is going to shift. It's the 3 to the minus x graph shifted 2 units up. So this shifts at 2 units up. Now it's a minus power, and so the graph we're expecting is this. So it's the decreasing hockey stick, if you will. But it's shifted 2 units up. Now, in particular, what that affects, if I shift this graph 2 units up, what also goes up with it?
The asymptote?
The asymptote, yeah. The horizontal asymptote is going to be raised. And so that's kind of the significance of shifting it 2 units up. So the horizontal asymptote will be at y equals 2. That. I would still get a couple of values here. Just to get the shape accurate here. If x is -2, we'd have 3 to the positive 2 plus 2, so that's going to be 11. 9 plus 2. If x is -1, that'll be 3 to the -1, so that'll be 3 to the positive 1 plus 2, so that's 5. 3 to the 0 plus 2, that's still 1 plus 2, so that'd be 3. 3 to the -1 plus 2, that's a third, so this is 2 1/3, or 2.33 if you wanted to write it as a decimal. And then x is -2. Well, that'd be a ninth. So a ninth plus 2, so that's 2 in the ninth, or 2.1111, I believe is the decimal for that. So that just gives you a few points to, like I said, get this accurate, pretty accurate. It's 11, so at -2, we're at 11. -1, I'm at 5. Where's 5? Here's 5. 0, I'm at 3. 2 1/3. 2 1/9, so it's getting real close to 2 right there. But so yeah, we've got the shape we were expecting. The horizontal asymptote is now at 2 there. So it's going to level off. You're not going to go below that line. Is that okay? Question or concern? One more. All right, so f of x equals 4 to the x plus 3. All right, so the plus 3 is up there in the exponent, and so that, technically speaking, that's kind of on the inside, what we were terming on the inside when we were talking about the shifts. And inside, adding or subtracting a number, what does that do? Makes it go left or right. So that's a horizontal shift, and plus 3, right or left. That'd be going to the left. Yeah, it kind of goes opposite of what you might think there. Yeah, so this is going to shift it 3 units left. So yeah, if you've got plus or minus on the exponent there, that's going to make it go right or left, and plus goes to the left, the minus 3 would go to the right. But now, this one, we've got 4, and it's just x plus 3, 4 to the x plus 3, and so which hockey stick are we talking there?
Increasing.
The increasing one, like that. And now it's going to shift it 3 units to the left. So if I put my same values here I've been doing, 4 to the -2 plus 3, that's just 4 to the 1, isn't it? And then 4 to the -1 plus 3 is 4 squared, 16. 4 to the 0 plus 3, that's 64. 4 to the 3rd. And then we're getting into some large numbers here. 4 to the 4th, it's 4 to the 4th. 256. And then 4 to the 5th, that's 1024, I believe, isn't it? Somebody check me on those, but yeah, so these, because of the shift to the left, these numbers on the right are getting quite large, and because we're on the increasing, but so -2, I'm at 4. At -1, I'm all the way already to 16. So there's 16. And then at 0, I'm at 64. I'm not even going to put that on here. But yeah, because we're talking about the increasing hockey stick exponential function shape, that's shifted 3 units to the left, and so yeah, these values over here are going to be quite large quite fast. The rest of it, so if we've got 3 units to the left, we might want to probably pick out maybe some more negative numbers instead of our regular ones here. Go with a -3, -4 instead. And that, on this scale anyway, would probably be more to our advantage. Yeah, because if you do x is -3, that gives you the 4 to the 0, right? Which is 1, and then 4 to the -4, that gives you the 4 to the -1, which is 1/4. so. So here it is. Now, we shifted 3 units to the left. What did that do to the horizontal asymptote? Well, it also shifted it 3 units to the left, but did that really change it? If I shift my horizontal asymptote to the left,
Still there.
it's still at 0, isn't it? Yeah, so a right or left shift is not going to change the horizontal asymptote because it's still 4 units to the left, 3 units to the left, it's still 0. You didn't raise it up or down, so. So we might note there, it's still at 0. Okay? Any thoughts or concerns on that? So a couple of those, have you graph a couple of those.